Okay, now I should be live. I've spoiled a tiny bit the video, but yeah, I should be live. Let's just wait for the audio to be here, since nobody else can confirm it. And it's quite an impromptu stream, but yeah, the delay is super slow, like 30 seconds. Come on, audio. Yeah, audio is there. So, it's an impromptu stream simply because I thought that I didn't do a stream for a long time, and this could be a good project for streaming. So this is a bike I bought recently for very cheap. It's an e-bike. It was very cheap because there was no battery. The thing which was here wasn't there. And I just plugged in the battery you saw in the previous stream with a step-down converter, because this is a 36 volts e-bike and the battery is 48 volts. But that worked. Now the issue I had is that so the pedal assist, so the motor which is there in the front, this wasn't working all the time. It was working sometime, and after one rain it stopped working. And the motor controller is right here. We'll have a look at it closer. Normally how the e-bike works is that it assists you in pedaling. So when you press on the pedal, then it gives a boost using the motor which is here in the front. This wasn't working anymore. I cheated actually. Let's have a closer look. I'll prepare. I also wanted to start this, trying to start with this streaming. Something I did not test. Multi-dashboard. You'll have a look at the camera until I finished. Project multi-dashboard. I'll need to enable to read from the multimeter. Connecting, and it blocks. I don't know why. Every time I started the first time, it just doesn't work. But the second time it works. Okay, now you have live updates from the multimeters. We don't use it now, but it will be easier. And now what I can also do is, no, it doesn't matter. Into screen this way. Yeah. Yeah, we can go a bit closer. So, yeah, the streaming is not ideal, but you will see what I mean. So how it works is you plug in the battery using the cable which is somewhere here. This is where you plug the battery. The battery goes in there up to, actually let's put it this way so you can also see it, up to this controller. This is actually the motor controller, and it's pretty easy. It has battery input, it has the pedal assist input, which is not there anymore, and then it has two outputs. One is these beefy wires. So this is the power input, these two on the back. This is the motor, which is a brushless DC motor. So you have always the three phases. And this goes up to the front, right there. And the second output is to display the battery voltage, but it doesn't work anymore. It's just red all the way. It also broke after it rained, so I don't know what happened. But what I cheated also is that normally you have the pedal assist sensor, which is right here. We'll have a look at it afterwards. And it goes up to here. Now I cheated for how it can work, and now I have a button to press, and this is just so I can test it. I want to fix it because I think legally you're not allowed to have an assist while you're not pedaling. This is why you have the sensor. So this probably isn't working, but this is just to debug. It's not to use it. And that's the motor. It has only 3 pins now. Let's have a look. Now we can switch the camera. Up, input 3, I can go, no, not here, on the bench. This I can switch off for now. And on the bench, this is the pedal assist. So there are plenty of ways to measure if you're pedaling. In the beginning, I really thought that how it works is that it measures the force you put on it, and the more force you put, the harder it enables the motor. That's not the case at all. It would be hard because you would need a strain gauge here on the crank or somewhere here. So probably you would put a strain gauge here or on the bar, and it makes it a bit hard because you need some kind of, it's not impossible, but slip ring so you can read the strain gauges, and then you don't have real good measurements. There are other ways probably to do it, but they don't do it at all like this. They do it a different way. What I've seen online, what the others do is that they have ring magnets everywhere here, and then on the other side, which is a sensor, you have a Hall effect sensor. It just, when you turn, then it recognizes, okay, you're turning, now I can give some power, and that's it. So it doesn't know how much force you put on it. I think it only knows you're pedaling or you're not pedaling. This is not the case here, and I just managed to open it. It needs some special tools, crank, and I think it's a crank pusher, crank removal tool, which I didn't have before. Now I have it, and I could remove it. And that's the board, and this is what we'll try to fix. This is the pedal assist sensor, and I found it a bit, clever. So let me show what is covered until now. So this is the sensor. What I know is that we have 3 pins. There is 1 times ground, there's 5 volts. And what I've discovered is on the blue wire, which is the backup, it tells how much of the assist you have. And this is an analog signal. At least this is what I found on the using the button. You go up to 5 volts, 0 volt is actually, it starts at 1 volt or something like that. It doesn't give any power. 5 volt, it gives full power. I don't know if this uses an ADC or if it gives something else. We'll find it out. If it does really scaling, because it was kind of broken, so I don't know what the intended use is. If it's just 0 or 5 volts, or if it really does analog. How does this work? Well, at least this is what we have to. Here we have 2 photo detectors or photo barriers. So one side is the emitter, very probably this one, infrared emitter. The other side is actually it's an infrared receiver. So I think this is the receiver, this is the emitter. Could be the other way around. It doesn't really matter. And it just detects if there's something in between, like up. Just detects if there's a blade in between. And we actually have 2 of them. Why 2? Because on this side, what we have on the crank are these metal parts. So it goes in here, and we have holes and spades. And so when you press on the crank, then, or when you turn the crank, it just turns this, and then you have always the pattern on off, on off, on off. This can be detected using this photodiode, this on off all the time. So this knows when you're pushing, and that kind of would be enough, but they're doing even more than that. They have a second one. Either they use it to detect if it goes backwards, and if they go backwards, then they don't put crank anymore because you're trying to brake and not to put some power. That might be one of the things. But actually on mine, if you go backwards, it blocks. So it's not really applicable. The other thing is that when you first crank in the beginning, you see that, or when you put on the back, there are 2 rings of these plates. And when you go to the back, it kind of closes the path. So there's still a bit of path, but it's a lot shorter. And when you press, it's a lot longer. So either what they did is a nice geometry, and then you will have never, if you do it this way, you will never have the both which are open, or you do it this way, and then there's always at least one which is open, and this way they detect when it advances. And we'll test it out. So this goes right here. That's where so I didn't look in the back. Okay, so this is conformally coated. You see this kind of shiny varnish, but there is some kind of rust here, so I need to clean this up, and also some of this on this capacitor. I think this is this doesn't give a signal anymore. We'll test it on the oscilloscope. We can test it on the oscilloscope or on the multimeter. Then I need to set this up. So let's get some power running. Up. 2 pins. 1, 2. It takes 5 volts. And we will test if it works. And I've measured the 5 volts. So in the motor controller, there's kind of probably one step down, then one LDO for the 5 volts. It's not showing you on the right one. You won't see the right measurements. Let's switch now. We're at 50 volts. 50 volts, which just... I hope I didn't break it now. I just applied 50 volts on this microcontroller. On this LTO. Probably this is... I didn't switch it off. Okay, maybe it's completely broken. We'll see. Now let's go to 5 volts and let's wait until it's down to 5 volts. Okay, now it's 5 volts. Let's switch it off, plug it again, and then we'll see if I broke it or not. Yes, I broke it. Actually, I didn't. Wow. It draws 250 milliamps. So it's not getting warm. It is getting warm. It is getting warm. I think the microcontroller is dead. Yeah, the microcontroller is getting warm. I don't know if I broke it or if it was broken before though. That's a shame. But I know this is dead now. Definitely. So I could reuse another. That's really a shame that maybe I broke it on the stream, and then the stream result. It's done. This is a very old microcontroller, AT89 C2051. It really gets too warm. That's not usual. 5 volts, 250. You probably just by touching it, I feel that this. Yeah, it's defective. Maybe it's defective because of the crud here, and there's a short. Let's clean this. And let's see if this is that. But I think the 550 volts which I put there killed it from the previous setting. Well, it would be a very, very short stream because it's not what I can do. So we have 2 op amps. I think these are op amps. I'll have a look at it. That would be my guess. Oh, I used contact spray. Just contact spray to kind of clean the contacts. I would guess, oh no, this is a diode. Okay, I would guess that this is the LDO, but it doesn't need an LDO. This would be a 5 volt part. And no, it was broken before. Probably. Here you see there's some discoloration. It's kind of purple. Let me zoom a tiny bit. It's kind of purple. It was purple before. So maybe it was broken from the start. And I didn't break it. It's still using 250 milliamps, which is quite a lot. And yeah, the microcontroller is getting, it's getting really warm. And here you would use 10 milliamps, something like that, or 20 milliamps times 2, but not 250. Yeah, very probably this has been broken, and probably the microcontroller on the display, which displays the voltage, has also also broke. There might, I don't know what happened. There might be a voltage surge or a contact which shorted everything and which killed it. Maybe I also killed it in the stream, you saw it live. Maybe not, but it was broken before. It didn't give any output, although it got power. Well, it's a short trip. And here you have Q. See, here you have the diode. This is the emitter. So this is the diode, and this is the transistor. You see it here, D and Q. One time, two times, and then you have the resistors to pull down or to limit the current. Then we have an op amp. Why would I use an op amp and not directly? So what are these parts? LM358. Yeah, these are op amps. Why would they use op amps? Because the signals are too small from the transistor for this, maybe. So yeah, the only thing I could do is get a new sensor, but a new complete passive pedal assist sensor. But this is not fixable. Not sure if it was in the beginning, but this is broken. Maybe these are also, but they're not. These ones are not getting warm, and op amps are generally very robust. Let me check. No, they're not getting warm. Only this is getting really warm. Damn it! No, this is broken. The discoloration probably is a discoloration from the lacquer, or I don't know. Maybe it was a marking. Yeah, I might have killed it. Well, it's a short stream. I wanted to check if it's still working, it's not working, and how it detects if it's outputting an analog voltage or if it's outputting just a digital 0 and 1. Because the motor controller supports analog values. But we won't know. This is dead. I need a new pedal assist sensor, and with that the stream is it's almost done. I'm not spending too much time. I wonder what this is. ICO. IC0. Sorry, IC0. That might be a voltage regulator. Yeah, might be a voltage regulator because it's using the input of the voltage, but they decided we'll not use that. We will directly use the microcontroller on there. I could reverse it, put another microcontroller fitting here. Oh, I don't have in this sub package. Design a new one, or just buy a new passive infrared sensor, which probably may be compatible with that. I don't know, but for now it's broken, and I think I'll end the stream. We know that this microcontroller is dead. Sorry for that. Don't know if I broke it, if it was broken before, but at least you know how this pedal assist works. At least these ones, because you have plenty of different models. And here you only have, and it's a clever idea. You have photo barriers, and this way it can check if it's pedaling at which speed, because you could check which is go here, and it could limit after some speed. And maybe if the speed is slow, it would output a high voltage. If it's turning slowly, it would output a high voltage, something like 5 volts, to give a boost in the beginning. And if it's spinning fast, it would give a slighter boost, but it doesn't know how fast you are, because after that you have other gears on the back, and it doesn't know which gears you shifted in. So it's only about giving power, not just knows how fast you're cranking. Yeah, clever idea. Either magnets and HAL is a good one. This one is also a good one. Both approaches are nice and really cheap. But yeah, with that, that's the end of the stream. I'm sorry for that, but at least you see what's inside here. We'll have to put a new device. Okay. Well, enjoy the rest of the time. Bye.